Warm up for lesson 4-4 complex numbers. Pause. And here's the answer. Pause. And here's the answer. Pause. And here's the answer. Lesson 4-4 complex numbers. Objective: perform operations with pure imaginary numbers. Perform operations with complex numbers. Let's take a look at this graph. When we graph the parabola, we can see that the y does not equal to 0 here. And if we use solver on the math menu, you still will get an error. Today we're going to talk about something that you haven't seen in your mathematics study so far, and that's called the imaginary unit I. And this is what its definition is. When we take I squared, it is equal to -1. If I were to take the square root of both sides, and then I would get I, which is equal to square root of -1. Now, I know we've told you before that we never have a negative under the square root, but today is when we change. We talk about a new number, and that's called an imaginary number. Okay, these numbers are pure imaginary numbers because they all have the letter I. And what does I stand for? It stands for root -1. Pure imaginaries are square roots with negative real numbers. For any positive real number b, if you were to have this, then this is going to be a -1 and we'll have a bi. All right, let's take a look at some number examples. Here is square root of 27. And we're going to have a -1 for the 27, and then here are the factored form for 27. We can see that right here is a perfect square, so we're going to be able to simplify it to 3. Square root of -1 is I, and then that square root of 3 we can't change. Now we normally like to put the square root at the end, the number at the front, and we'll say I in the middle right here. Over here, 216 is -1, 6 squared times 6. Again, the square root of a square is going to be a 6. This is going to be square root of 6. We like to put the root at the end, the I in the middle, and then the 6. Okay, so let me do some by scratch. Okay, so this is going to be equal to square root of -1 times, and I know I have a 3 squared times 2, because this is 9 times 2. And I know that when you split them all up like this, then I'll have a negative, I'm going to have an I, and then I'll have a 3, and then I'll have a root 2. Now we like to have the root at the end and the I in the middle. There we go. Okay, now this one will be square root -1 times, now this is going to be 5 squared times 5, 25 times 5. I'm going to split them all up into their square roots. This is going to be I, this is going to be a 5, and this is root 5. And I like to rearrange it, 5i root 5. And that is called an imaginary number, pure imaginary number. Your turn, pause, and here's the answer. All right, let's take a look at powers of I. Okay, so this is I to the first power, it's I. And remember, this represents root -1. Now, if I were to take root -1 and times it to root -1, the answer will be -1. So I squared is equal to -1. Over here, I cubed is root -1, root -1, root -1. And I know that this is going to be a -1. And then I know this is I right here, so that's why we say the answer is -I. Now I to the fourth is root -1, root -1, root -1, root -1. Now these two are going to make -1, and these two are going to make -1. So -1 times -1 is +1. Okay, so let's take a look at I to the fifth. Now I to the fifth is I to the fourth times I. We already know that I to the fourth is 1. So this is really 1 times I, and so the answer is I. I to the sixth is I to the fourth, and remember that's the number 1, I squared, and we've talked about I squared being -1, so this answer is -1, and so on. This is how we do it. Okay, let's take a look at simplifying. Simplifying, we're going to multiply the two numbers, and that'll be negative 15, and I are going to make I squared. Remember that this part right here represents a negative 1, so negative 15 times negative 1 will be 15. Right here, let's go ahead and write it in terms of I. So this is I root 6, I root 15. The two i's are going to multiply to be I squared, and we know that I squared is negative 1. We simplify the root 90 to root 9, root 10, and then we'll have negative 3 root 10. Okay, what about this one? Well, this is going to be 12I squared, and up here I squared is negative 1, so we can call this negative 12. Now this is going to be I times root 20 times I times root 12. So this is going to be I squared, and we are going to have a 2 times 2 times 5, and then 12 is 2 times 2 times 3. So I can see I'm going to be able to, I have an even number here, I have here and here. So that is the number 16. So I can rewrite it. I'm going to write it up here. This is going to be, I squared is negative, and then this is 16, so that's going to be a 4, and then everything else has to stay in the square root, so that'll be 15 right here. Now I 31, remember, is I to the 4th times I to the 4th times I to the 4th times I to the 4th. Let's see, that's 16 of them already. I to the 4th, I to the 4th, I to the 4th. So this is 1, 2, 3, 4, 5, 6, 7. That's 28. And then I have I to the 3rd. And then these 28 i's plus 3 more i's are going to make I to the 31st. So we know all of these are all 1, 1, 1, 1, 1, 1, 1. And we know that I to the 3rd right up here is negative I. So the answer is negative I. Okay, your turn. Pause. And here's the answer. All right, let's talk about the square root property. Square root property is a way to solve for x when the factoring will give us real numbers. Okay, so this isn't a difference of two squares, so we can't go around factoring it, but we can move the 64 to the other side, and we can take the square of both sides. That'll be plus or minus root negative 64, and this will be plus or minus 8i. Now we can use a factoring method. I will talk to you more about the factoring method at some other time. So right now I'm just going to do the square root property. Okay, so I'm going to move the 10 to the other side, and then I'm going to divide both sides by 4, so that's negative 25. And now I'm going to take the square root of both sides, but remember, when you take the square root, don't forget the plus or minus. And I'm going to go up here with more room, and then this is going to be x is equal to plus or minus. And remember that square root of 25 is negative 1 times 5 squared. So this is going to be plus or minus. Now we know that's going to be I, and square root of 5 squared is 5. Now normally we like to put the 5 in the front, plus or minus 5i, like that. Okay, over here we're going to do the same thing. We're going to move the 4 to the other side, and we're going to take the square root of both sides. Don't forget to put plus or minus. So moving over here, I'm going to have x is equal to plus or minus root, and remember negative 4 is negative 1 times 2 squared. So this is plus or minus I, and square root of 2 squared is 2, and this is kind of awkward. You'll like to put the number in the front of I, and so here's the answer. Okay, your turn. Pause. And here's the answer. All right, let's talk about combining this pure imaginary number with a real number. So 2 is a real number, and 3i is a pure imaginary number. So when we add them together, we get what we call a complex number. It's imaginary plus real. and this is also imaginary plus real. And so now we're going to have another set of numbers other than the real numbers. They're going to be called the imaginary numbers. All right, so let's go ahead and we are going to look at some imaginary complex numbers and take a look at the real part and the imaginary part. Okay, so the part that has the I in it, this part right here, is called the imaginary part, and it's going to be equal to the imaginary part over here on the expression that's equal to the other side. So we're going to set y minus 3 equals to 6, and then y is equal to 9. All right, now I'm going to take the real part, this is the real part right here, and set it to the real part of the complex number. I'm going to set them equal to each other and then solve. All right, let's go ahead and do this as well. I'm going to do the real part, this is the real part, equal to the real part over here. So this is going to be 5x plus 1 is equal to 2x minus 2. This is going to be 3x plus 1 is equal to negative 2. 3x is equal to negative 3. X is equal to negative 1. Now I'm going to do the imaginary part, the expression in front of the I, set equal to the expression in front of the I. So this is going to be 3 plus 2y is equal to y minus 6. So this is going to be 3 plus y is equal to negative 6. So y is equal to negative 9. Okay, your turn. And here are the answers. Real to real, imaginary to imaginary. Now I know I put the i's in there. I really could have just done the negative y to 2 and skipped this step altogether. Okay, so let's talk about adding and subtracting complex numbers. So when you add complex numbers, what you want to do is you want to add the real part to the real part. So that's going to be our 7 here. And then you're going to add the imaginary part right here. I should include the I here. This is the imaginary part with the imaginary part here, and that's going to create this number right here. Now when you're subtracting, you have to remember to distribute. So then we know that this is going to be 4 take away 3 for the real part, and then this is going to be 8i plus, it'll be a negative 8i plus a 6i, and that's going to give you this answer right here. All right, let's go ahead and do this problem. I want to add, so I'm going to add the real parts to the real parts, and that'll be negative 1. And now I'm going to add the imaginary to the imaginary, and that'll be negative 2i. Now remember to distribute. A lot of us distribute first. So it's 4 plus 6i. That's plus 1 minus 2i. So now we can do an addition problem. The real parts are going to be 5, and when you add the imaginary parts, that's going to be plus 4i. All right, you try it, and here are the answers. This is the end of part 1.